I would like to help you understand the capabilities and limitations of AI systems by explaining the basics, the fundamentals of AI. And I call this part AI Explained by a Liberal Arts Major. I am a liberal arts major. I am not an engineer. I am not a data scientist. But here is how I've learned to think and to explain AI to others in ways that are easy to follow and understand and useful. So first of all, AI is everywhere. And it has been everywhere for quite a few years. We hear about AI and generative AI a lot these days, but this is not a brand new technology, even though some of the advances are a little bit different and perhaps revolutionary. But we have seen AI in your social media feed, in the way it organizes your feed based on what it estimates that you might be interested in. We've seen it in shopping recommendations, at airports with facial recognition, and when we use maps to navigate our way around. Now, what is all this AI and how do all of these things work? Basically, it helps to think of AI as probability machines. So AI or machine learning models use tons of data, which is information about the people and the world. And as they mix and match that data and process it, they identify patterns. This is math and statistics and a little bit of automation in the fact that these machines are able to recognize some of this work without being told exactly what to do. But then based on these patterns, AI models output probabilities. What does this mean and how does this work? Let me show you some examples. So let's say you have recommender systems, and these are systems that might recommend the next product to buy, the next movie to watch. Actually, what these types of AI models do is they output the probability that a given user is interested in this item. If the probability is sufficiently high, they're going to show it. If the probability is not sufficiently high, they're just not going to show it to you as a recommendation. Let's look at a few more examples. Facial recognition. The output here is really the probability that this is the same person. So when you go to the airport with your passport and your boarding pass, and you might not look the same way you looked when you took that passport picture, right? And so again, there's a matching which says, what is the probability that the person that we have in our system in the passport is the person today, the face? What is the probability? Same thing, if you use these photo album organizers, they recognize people and even pets, and they can say, okay, which are all of the photos of my husband, which are all the photos of the white cat, the black cat, and so on and so forth. Again, the way they work is, what is the probability that this is the same person? Should I group this photo with the other pictures or not? Medical imaging. We have AI systems that are used in medicine. Not a miracle here. What is the probability that this image shows signs of cancer? Right? And so again, it's a probability. Even if it's, I hope not, but even if it's 98%, there's still room for error because of the probabilistic nature of these systems. But we also have to be careful because there could be some validity issues. So for example, there are some systems that purport to recognize people's emotions based on photographs of their faces. And so if you look at the pictures here and you're asking, what emotion is this person feeling? Based on that photo alone, even for a human being, it is very, very hard to tell. To me, it looks like she's in a lot of pain. And in fact, it seems that she just won or scored a goal or something in a sport. Okay. Similarly with gender or inference of age or race based on photograph. Here is where we have a validity issue where AI is not fit for this particular purpose. In this particular case, we don't have reliable data to begin with because people themselves can't really do this task very well. So we have to think about when are AI systems, when is machinery, right? When are machines fit for the task, for the purpose, and when they are not. Now, let's turn a little bit to another type of AI that we are hearing a lot about these days. And this is a type of generative AI, large language models. What do they do? Well, really what they output is the probability of the next few characters or tokens in a string of text or code. Now, they seem like magical machines, and they seem like they can do a lot. And they can. But we still need to understand the basics, because that's going to help us understand some of the limitations. And so we're going to be talking a little bit more about generative AI, what it is, and how it is different from other kinds of AI. Let me try to spell out a little bit of explanation of what is generative AI. Well, so generative AI is, of course, type of AI, but what they do is they output strings of text, of code, images, video, music. Large language models are one type of generative AI, and they output text and code by calculating probabilities. And large language model examples are GPT-4, Claude, Gemini, Llama, and so on. So let's look a little bit into LLMs and how they work. I mentioned that large language models predict the probability of the next token. So they don't even work in words. Sometimes, like in this example, a word is a token. In other instances, a token can be just a set of a few characters, not necessarily a full word. So here we see an illustration where you input the words "the sky is" into the LLM, which is a neural network, but we're not going to go there. And then you see the probability of the next words, right? Blue has a higher probability than clear, than usually, and so on and so forth. And therefore, based on likelihood, it completes the sentence with "the sky is blue." So I hope that this dispels some of the myths and some of the magic around large language models and generative AI. But I want us to look a little bit deeper into a few examples and try to figure out what we can infer about how these machines work and how much we can and cannot trust them. So something that's been circulating on the internet lately is this kind of tricky question for a LLM, where you ask how many R's are in the word strawberry. How many R's are in the word raspberry, right? And as you can see here, the answers are incorrect. The answers are, there are 2 R's in raspberry and strawberry respectively. Now, we don't know exactly why this happens, but if you think in terms of probability of what words come next, and if you think about the fact that the data that these systems are trained on is language, text that's found online, right, on the internet. And so many times people might ask, how do you spell strawberry with how many R's? And the answer that I would give you in a casual conversation would be 2 R's, because I know what you're asking about. I know what you're asking about, the berry part. And so my hypothesis is that because that is a common answer and because that can be encountered probably in many online forums, that's why the probability for 2 R's is higher, and you get this kind of answer. Now, let's be careful here. I'm going to continue this example because sometimes people check, oh, you should verify the answers, and you should verify. But here I try to ask it, are you sure? And actually, we know, we've observed this kind of behavior from large language models. When you ask them, are you sure? They tend to double down on their response, which was erroneous in the first place. So here we note how there might be different strategies for poking and probing and iterating with a large language model. And we need to learn some of these, right? Because we need to learn and to adjust to how this technology works. So it's important to remember a few things. Out of the box, large language models can generate text and code, and by generating probabilities based on patterns that they have observed in the training data. So because of this capacity, they can summarize text, they can even answer questions given a piece of text or given a question. But remember that they don't search the internet. They don't have knowledge. They only have probabilities of what words typically occur after other words in a huge amount of text that they have used in their training data. Large language models do not learn. Okay, it's important to remember GPT, the P in GPT, generative pre-trained transformer, the P stands for pre-trained. it is very labor intensive and it is very expensive to train a model like this. And so they're not going to learn from user behavior. So for example, if you ask them to summarize a paper, right, they're not going to remember what was in that paper and the next day tell you more about it. Granted, that paper might be stored by the large language model builder, so they can use it in a different training run, okay? But they do not learn, they do not adjust the way, for example, recommender systems might adjust, right? So if you're on a shopping site and you bought something or you liked a blue shirt, then you keep seeing more blue items or more blue shirts, right? That kind of model learns and adapts to the user behavior on the spot. These large language models do not do that. And it's also important to remember that LLM outputs may be inaccurate. They might be incomplete, they might be inappropriate, or offensive and biased. So let me show you an example, then you'll see like how does it work there? Because I've seen pretty good answers. I've seen pretty good examples, for example, on the web on these things, and even in ChatGPT and Microsoft's Copilot. So what we've done, we have mixed two technologies. We have mixed search with large language models. And this is the process, roughly speaking, this is how this works. So when you use an LLM enhanced search, such as ChatGPT or Microsoft Copilot, this is what happens. So first, as a user, you ask a question, you put in a prompt. Then the search engine retrieves relevant pages with that information. The LLM comes in and summarizes the content of the retrieved pages. Occasionally, the LLM will not do a summary and it will just answer based on its training data. You can't really know or control how that happens. And then the LLM output is usually passed through some safety filters, some responsible AI filters. And this is where we try to block content that's inappropriate, offensive, biased. And if it passes, then the content is shown to the users. But several things can go wrong here. As you very well know, if you've been an internet user for a long time, just because you search for something online, it doesn't always mean that you're going to find the correct information. So there can be errors that happen at the search layer, but there also can be errors that happen at the summarization layer. Right? Because as an LLM summarizes information, it might make mistakes. It might represent something inaccurately, or it might miss out some of the things that were in the text. So I hope this explanation is useful and helps you understand a little bit of, how do these things work under the hood, so you can understand maybe where could errors come from. So generative AI, first of all, can do very many things, right? It can generate recipes, it can do a SWOT analysis, it can write a poem about your cat. Now, another type of more traditional AI system, like a recommender system, is not able to write poems about cats. It is only able to recommend and say, this is the probability that this person is going to like this item. So it's much more richer in the types of applications that we can use it for. As I mentioned, generative AI works with models that are pre-trained, and so it does not learn from user behavior. And also, you could have the same input given by the same person or by different people, but you might get different results. And you can try this by using a prompt and then clicking regenerate. And then you'll see that there are differences in the outputs that you get for the exact same prompt. Also, generative AI is more collaborative, right? You can converse with it. You can engage in iterative prompting, and thus you can improve and refine the output of the AI system in a way that might be a little bit more difficult with other types of AI. So let me give you an example that once again illustrates some of the things I've talked about. So as you might have noticed, LLMs are not very good at math. So here I posted a math query. I asked it to calculate something. It gave the wrong response. And then I tried to use a prompting technique that's used explain your reasoning. And that's where you ask the LLM to break it down by steps and explain the reasoning. And once it did that, this one time it worked and I got the correct answer. However, if I tried again, it explained its reasoning, same input, I got a different output. Okay, so I hope this example shows, right, why are they not good at math? Because really, it's the probability of the next token coming up. And so if there are very simple things like 1 + 1 = 2, right, that they have probably seen in the training data repeatedly, it's a lot easier. But other than that, these are not math machines, and that's why they're not super good at math. But then, okay, I showed you how, I could use a type of prompt to try to get it to do better, and it did do better. But also, if I repeated the prompt, again, same input, different output, right? Illustrating some of the workings, some of the behaviors of large language models. What is generative AI good for? Now, different people will tell you different things, and I must be honest, this is really my opinion. It is a well-informed opinion. I obviously work in this space and have thought about these things a lot. But what I find generative AI and large language models really, really helpful for is brainstorming. So oftentimes I will write a paper or a presentation, and I have a hard time coming up with a catchy title. And so it's really, really good for brainstorming. And I ask you, give me 5 or 6 titles that I can pick from. And then I play around with these titles. And so it helps me brainstorm ideas. It helps me, this is one of my weaknesses, right? I can't come up with catchy titles. And that's where it can really help me out. It also helps me make sense of large amounts of information. If there's a large amount of information that I do not have the time or the need to understand in detail, I can query it using the large language model. So I can open, for example, the PDF in Microsoft Edge and then use the Copilot bar on the side to ask questions. Not only summarize this, but what does it say about A? What does it say about B? What are the pros and cons that it mentions? And so I can get very quickly an idea of what's in that large quantity of information without having to read everything line by line. And of course, there are scenarios in life where that is useful, and there are scenarios in life where that is completely not appropriate, right? For example, the person who's building the airplane I fly in, I hope they're reading their textbook much more carefully than that, right? And then it helps me get a general idea or a reminder of a topic. So if there's something that I haven't really studied in a very, very long time, I know something about, but I really can't remember. It's been 20 years. I might query Copilot or a large language model application. It's going to give me a summary that's going to jog my memory. And because I am somewhat familiar with that content, I can pretty much eyeball and figure out, okay, this makes sense. This is what I remember or not. Or I need to get a general idea about a topic. I don't need to be an expert, but I need to learn the basics. So if I'm giving a talk to a customer, for example, I need to learn. I've never heard of the company name. What do they do? What are some of the challenges in this market? It doesn't need to be precise. I'm not going to use that for any, high risk scenario, but I could very quickly get an idea that's helpful for preparing. And also, it's really helpful as a writing aid. There are times when, even though I love writing, but just the other day I had made a mistake. I do not like to make mistakes. And then I had to write an email to a large number of people explaining the mistake that I made and how I was going to take action on it. This was a hard email for me to write. And I was sitting there being frozen. And then I see Copilot in Outlook and I go, okay, Copilot, this is what I did. I made a mistake. I need to apologize. I need to say this and this. Can you make it? Can you draft it? Can you make it sound formal? And it came up indeed with some pieces of text. I ended up changing some words here and there, but it helped me a lot. This was an emotionally charged moment. My brain was not working properly. And so it was helpful for me as a writing aid. But again, I probably wouldn't use generative AI for something that's really, really high stakes or something that requires a lot of precision, a lot of nuanced, detailed information. If I have that need, I might use it as a first pass and then go deeper into the topics, making sure I verify the information it provides. So keep in mind, when you use generative AI, first of all, keep in mind that even though it acts and it seems very human, it's actually a probability machine. It does not feel, it does not think, it does not understand in any real way. Okay, it doesn't have a body, it doesn't have memory, it doesn't have a life experience. It's never seen what a cat looks like, right? It's never smelled good food. It's really just math. Okay, keep in mind, as I said, that it might not be appropriate for tasks that require high precision and accuracy or are high stakes. And also, I know that many people use it to offload and to say what's on their mind. And this might be beneficial in some cases, but it's not a friend. It's not a companion. It's definitely not a therapist. So even though it can output text and it can output language, please remember that nothing can substitute people in our lives. As you are using generative AI, I would love for you to be smart. And so these are some of the things that I think about. First of all, decide, is generative AI fit for what I'm trying to do right now? Also, check its outputs for accuracy and for completeness. Be aware of this phenomenon that's called over-reliance on AI. Over-reliance on AI, accepting AI outputs even when they're incorrect, can happen for a variety of reasons. It can happen because of something that we call automation bias, where we think, oh my God, computers, they have so much more processing power, so much more information than human beings. It can happen for a variety of reasons. I invite you to learn more about over-reliance on AI and be aware when that might be happening to you. And then try to learn how to maneuver, right? Like a powerful car. Try to learn prompting techniques that could help you get more out of generative AI applications, and that can help you overcome their biases. Knowing that they're biased because the data on the internet is biased, you might need to be very purposeful in asking. For example, if you ask for to generate a photograph of a CEO or a group of doctors, you might need to specify what demographic characteristics that you want women included in the picture, and so on, to compensate for this particular weakness of generative AI. And with that, I really hope that this is helpful to you, that's going to make you a little bit smarter and a more powerful user of these phenomenal technologies.